In this section, we'll discuss thermal expansion. As the ocean gets warmer through various inputs of heat, its temperature goes up and it occupies a greater volume. In discussing thermal expansion, it's important to address ice albedo effect. In essence, as the extent of sea ice goes down, less incoming solar radiation is reflected into space and more of it is absorbed by the dark ocean beneath. And this process really reinforces itself because as the dark ocean is exposed to more incoming solar radiation, it warms and melts sea ice faster, which just makes the entire cycle occur faster and faster. And once the ocean gets warmer, its molecules vibrate more rapidly, and that's what causes it to take up more room and contribute to sea level rise, as we'll see in the next two slides. Now that we've discussed thermal expansion, we can discuss land-based ice and how that affects sea level rise when it melts, which, as we saw earlier, is responsible for about 60% of sea level rise over the past 50 years. So when sea ice melts, it does not raise sea level because it displaces water equal to its own mass. So when the sea ice melts away, the water just readjusts and no change occurs. But this is not the case with land-based ice. And there are two major areas that are of concern to climate scientists, and those are the Greenland ice sheet and Antarctica in general, but particularly West Antarctica because it's at a lower elevation than East Antarctica and is exhibiting more melting than any other part of the continent. And there are two terms that are important to cover here. Those are ice sheets and ice shelves, and they're not the same thing. Ice shelves are glaciers that are attached to continents but float on the water and don't really contribute much to sea level rise when they melt. But they are important in that they support ice sheets and keep the ice sheets from flowing into the ocean. And ice sheets are just continental glaciers because their mass is supported by the land, so they don't really contribute to sea level rise until they melt. A 2-year-old study conducted by NASA explained that in 2006, the Greenland and Antarctic ice sheets lost a combined mass of 475 gigatons into the ocean. That's about 1,045 trillion pounds. And this, if it continued, would be enough to raise sea level by about 1.3 millimeters each year. The really alarming part of this study is that over the 20 years that they were gathering this data, the two ice sheets were losing a combined mass of 80 trillion pounds more than they were the previous year. So if this keeps up, some estimates say that by 2050, sea level worldwide could go up by 6 inches. And 6 inches might not sound like a whole lot, but as we'll see in the later portion of this video, that 6 inches is a huge, huge deal for areas that are either subsiding naturally or are very close to sea level to begin with, and this small change, seemingly small change, could put them underwater. According to Eric Conway of NASA, Antarctica has been losing 24 cubic miles of ice per year since 2002. This is worrisome for some scientists because this enormous rate, as we saw previously, is actually accelerating. Another thing is that ice shelves work as support structures for glaciers on land and keep them from flowing off the continent. As Michael Shodlock explains, when the underside of an ice shelf makes contact with the relatively warm ocean, it begins to melt and hastens their collapse. This is one reason why Larsen B collapsed, which was the ice shelf covered in An Inconvenient Truth. Lastly, meltwater also affects ice sheets because pools of melted water that form at the surface eventually make their way down to the bedrock and lubricate the base of the ice sheet so that it is more likely to flow off the continent into the ocean. Now that we've explored the science behind sea level rise and how it works, let's turn to some of the effects of sea level rise. In its 2001 report, the IPCC estimated that between 1993 and 2008, there would be at most 1.9 millimeters of sea level rise per year. However, in its 2007 report, the IPCC explained that there had actually been 3.4 millimeters per year of sea level rise, which is 80% faster. This shows that sea level rise is actually accelerating, and that's a concern. The IPCC also in its 2007 report then estimates that by the year 2100 we might have between 26 and 59 centimeters of sea level rise, which is at most 2 feet. But the IPCC assumes that Greenland and Antarctica melt rates will not change, and other studies have feared that these melt rates will in fact increase dramatically. As a result, the University of New South Wales, in its Copenhagen Diagnosis Report, which was released in 2009, estimates a rate double that of the IPCC by 2100, which would be about 4 feet of sea level rise at most, due to current input from Greenland and Antarctica. But we don't know that these rates will remain the same, and there's a good chance that they will continue to increase, as we saw in the IPCC's admission that it had been wrong in its 2001 predictions. And for all we know, total sea level rise could be 6 feet or even 10 feet by 2100. I'm going to focus on the Mississippi River Delta here because it is the area of the United States that is experiencing the highest rate of sea level rise because the delta is subsiding while sea levels are rising, and also because the area is biologically and economically significant. The reason why the Mississippi River Delta is experiencing such high rates of relative sea level rise is because as global sea level rises, the delta is also subsiding. So as it moves down, global sea levels are also moving up. Because of this, approximately 17 square miles of wetlands per year were lost from 1985 to 2010. The problem is that, as we saw earlier, Greenland and Antarctica are collectively contributing 1.3 millimeters of mass to the ocean per year, but these rates are increasing. So there's a chance that these rates of wetland loss in the Mississippi River Delta might double in less than 10 years if Greenland and Antarctica continue to increase their rates of melting. The reason why the delta is subsiding is because sediments naturally compact over time as water and gases are squeezed out and pore space decreases. As you can see in this little diagram here on the right, the image on the right shows compaction because the pore spaces are now much smaller and anything that was between them was squeezed out. This has the effect of lowering the surface of the land and causing it to sink. Usually, deltas can survive if the rivers are allowed to cyclically overflow and deliver new sediments to counteract some of the subsidence. But after the Great Flood in 1927, an extensive series of levees were constructed along the Mississippi River, and now most sediment is not allowed to overflow into the wetlands, but is instead funneled offshore, and that is one of the reasons why subsidence is so high in this area. With this graph, we can see that the rates of oil and gas extraction, the green and red lines, coincide with the highest point on the black line, and that black line represents wetland loss. So we can see that there might be a strong relationship between the two. Now that we've explored why the Mississippi River Delta is experiencing such high levels of sea level rise, let's look into some of the impacts of that sea level rise. Well, first, we know that 20% of domestic shipping goes through the ports along the coast of Louisiana, so those ports would be damaged if seas continue to rise. Also, approximately 1/3 of domestic energy production, as well as the infrastructure needed to produce and transport it, are located along the Mississippi River Delta, and that infrastructure would be damaged if seas continue to rise. In addition to that, about 5 million birds that migrate during the winter pass through the area to rest, and it's biologically significant as well. Lastly, about 3 million people live along that coast, and their jobs and homes are likely to be adversely impacted if the sea level continues to rise at current rates.
This Earth is the one we have to care about. It's the only Earth that we